We're solving majority element problem from Leetcode. So let's go through problem statement. Given an array of size n, return the majority element. Majority element is the element that appears more than n by 2 times. You may assume majority element always exists in the array. So this means we are given one array and there is one element that appears n by 2 times. We need to find that one. So there are multiple ways to solve this problem. So let's start with like basic force discussion. So with brute force approach, what we can do, we can just go over entire array one time, and for each element we'll be counting how many times this element is appears. If element appears more than n by 2 times, that is the majority element. So let's write the code for that one. Just going through all the elements in outer loops. For the I loop, I is equal to 0 and I less than dot size and I plus plus. For each element, I'm declaring count variable, and after that, I'm iterating to array once more. And in that iteration, I'm counting like how many times that element appears. So we got the count. Now what we can do, we can check like count is greater than n by 2, and NMB dot size by 2. Let's declare an answer variable also. So, so if current element nums I appear more than n by 2 times, that is more than half of the array, we will be returning that element. So let's return that. So this will be the solution for this one. So let's go through both examples. So for the 3 one, uh, first I will be 3 and we'll iterate entire array and we'll get count. We'll count for 3 is 2, and that is like more than n by 2 because n is 3, and divided by 2 will be 1.5, so that's greater than, so we got majority element. For this one, we will start with a 0th index and we'll count, and so 2 is appeared 4 times, and that is greater than n by 2. That would be like 7 by 2, 3.5. So 4 is greater than 3.5, so 2 is our majority element. So let's analyze time and space complexity. Since we are using two nested loops over here, so the time complexity will be order of n square. square, and the space complexity will be order of 1, since we are not using any additional space. So now, since this time complexity is not good, so what you need to do, improve upon that. So there is one more solution, like we can use hash map to store the values, all the values. So what we'll do, we'll create a map, and for each element it will count those values in one loop, and then we will iterate over the map and check if any numbers count is greater than and right. So let's write code for that one also. Let's declare the map first. Now I'll be iterating over the entire array and counting repeated elements. So what I'm doing here, let's assume we are going through this array. So for 3 we are increasing count for 3 is 1, so that would be 1. And after that, after that we are increasing count for 2 is 1, that would be 1. And then we will be increasing count for 3, that would be 2, because previous value was 1. So now go entire map and check uh, which element is appeared more than 2 times, no, more than n by 2 times. So the majority element variable. So the key will be majority element. Let's return that. So for this solution, since we are using single loop 2 times, so complexity will be reduced to order of n. This space complexity will increase since we are using additional 1 map. So this is kind of space-time trade-off. Let's try to run this code. Okay, there is some error. So undeclared variable. Okay. Okay, again I'm using unused identifier. Okay, so this one works. Let's try to submit this one. So this solution work. This is like perfectly fine solution if you see, but there is a follow-up question. Can you solve the problem in linear time in order of one space? So we got the linear times, we need to reduce space to order of one. So there is one standard algorithm for this one, of Morse voting algorithm. So the idea is like canceling out elements. So let's assume we are going through this array. So we'll take this 3 as first element, that is 3, as our majority candidate. So from here we'll move to next index. So let's do some calculations. Sorry. So we'll take like first element as majority candidate, that is 3, and count for that one in 1, since it happened one time, and then we'll be cancelling out that one. So next element, that's not 3, so we'll reduce the count. 3, first 3 is cancelled out, and now our majority candidate will be updated, that will be 2, and count will be 1. Then we'll move to next step, next element, so that is 3, and since majority candidate is different from 3, so count will be 0, and since count is 0, our majority candidate will be updated. Since we look through entire array, so we can just return the majority candidate, and 3 is the answer. So let's go through a bigger example. So let's erase the code also. Okay, so let's take this example for us, for instance. So initially our majority candidate will be 2, and count will be 1, the majority candidate. So first element is 2's, where we started like we set the majority candidate, and after that second element is also, so count vote count will increase, and then the next element is 1, so vote count will decrease, and next element is also 1, that is not majority candidate, so count will be decreased. Since count is 0, so we'll update majority candidate 1 and increase count to 1. We are gone through here. Then next element is 2, so count will be decreased, and since count is 0, we will update our majority candidate and set count to 1. Now last element is 2, so count will increase since element is same. So this way we are cancelling out all the 2's and increasing the count. So if you see what we are doing here, we are cancelling out the values. So these 2 cancel with these 2, and the 1 is cancelled with 2, and at the end of the day only 1 2 remains, that is our majority candidate. Let's write some code for this one. Let's initialize count as 1 and set majority candidate as the first element. Let's do one more check, like array is greater than 1. Yeah, looks like it's greater than 1, and it starts from 1 to 5 into 10 to the power 4. Since we already entered the first element, let's start or do from 1 and check if now majority candidate. Increase the count as we discussed. Decrease the count, and we'll check like if count is count is 0. Count is 0, we will increase, we will update the majority candidate, current number, and count to 1. And now, on everything, we will just return all majority candidate. Let's go through this code with an example. Let's take the bigger example, 221122. So okay, let's minimize that one too. We'll have more access to the code this way. Okay, and so initially majority candidate is 2. So and count is 1. Next, we're looking through the array since nums we'll go through this statement first since next element is 2. So candidate will be the same and count will increase. In the second, in the third element, we will be getting 1, so that's not equal to 1, so count will be decreased. But since count is not 0, we will not update the majority candidate. And after that, next element is also 0, so count will be decreased. And since count is 0, we need to update the majority element and the count. And so then this element is 1 again, so count will be updated to 2. And next element is 2, so count will be decreased by 1 and majority candidate will be the same. And next element is again 2, so count will decrease and majority candidate will be updated. So count will be 1. So I think when I was doing last time, I did some miscalculation and the count came as 2, but technically it doesn't matter, but there was some calculation mistake from my end. By default the count will be 1, so these two cancel out with the first 2 and this one cancel out with 1, so final vote count will be 1 only for this 2. So this solution looks good to me, and let's try to run the code. Okay, majority candidate, I forgot to declare the variable. I hope this will work. Yeah, looks like this worked. Let's try to submit our solution. Okay, this worked. Let's analyze time and space complexity since we are using one loop for n size, so our time complexity will be order of n. So time complexity, and since we are not using any additional space, so space complexity will be order of 1. So looks like this resolved the issue in the follow-up question. So we managed to reduce the space complexity to constant time, and our time complexity is also linear time. So the solution looks good. That would be it for this video. If you like the explanation, please like the video and subscribe the channel. Thank you. Bye.